Okay, today we're going to talk about inequalities. We're going to do some notes on inequalities. These are the same notes we did in class today. Key things, a couple things here. Remember what the definition is. Remember, if you're having any kind of trouble with your signs, your symbols, use a number line right up here. This side of my arrow pointing to the left, those numbers, as we move to the left, they're getting more and more negative. That means those numbers are less than. If I've got my arrow here that's pointing to the right, those numbers are getting larger. That means it's greater than. So if I just take a look at this symbol here and I can't remember, if I look up here to my number line, I should say that's less than. This one here goes this way, that's greater than. These should be easier to do because this is the same symbol, less than or equal to. So you have to remember that part, less than or equal to. This is greater than or equal to. This one here is not equal to. So that's where you're slashing out the equal sign. Some words we need to make sure we know for translating inequalities. Some of the words kind of go along with what we've done before. If I say 5 less than a number is 10, we use that word less than, 5 less than a number, but we mean it as subtraction. But we also have, though, the word for the equal sign, which is or equals in that sentence. In this case, when we're looking at this, this means less than. So we might say that 3 more than x is less than 12. In which case, we might then, that's where we're adding, and then we have this as our sign for less than instead of an equals. So these inequality symbols kind of, again, substitute in for an equal sign. We have our greater than, more than, or exceeds for greater than, obviously. These ones here get a little tricky because we're talking here that for this symbol here, this is less than or equal to, but that means it's no more than a number. That would say like x is no more than 5. That means it could be everything less than 5, but when we get to 5, it can't be anything more. It's no more than that. Here is the flip side of that, no less than something. So x is no less than 6, let's say. That means 6 is here, and x cannot be any lower than 6. It's got to be all the numbers that are larger than 6. Some examples here to writing inequalities. A package must weigh less than 10 pounds. That means x is less than 10. You must be at least 18 years old to vote. That means I can be 18 or older. So that's greater than or equal to. You must be over 50 inches. That means it has to be everything bigger than 50 inches to ride the ride. Your speed must be at most 65 miles per hour. That means x is everything that is less than 65 or equal to 65. So less than or equal to. But again, I stop at 65. I can't go past 65 for x. It can't be 70. For this second part here, you're looking at true or false. So we're literally just doing the math to see if this is a true statement or if it's a false statement. They're telling me that n is equal to 18, so I'm going to plug it back in here. That means 18 minus 6 is less than 15. I'm going to solve it just like I would an equation or an expression. This side here means 12, so 12 is less than 15, true statement. Here I have an 8. I'm going to plug in 8 for p. So negative times a positive is a negative, and then 3 times 8 is 24. Negative 24 is greater than 24. That's a false statement. Not only is it not greater than, it's also not equal to. That's greater than or equal to. It's neither. So that's a false statement there. Here I'm plugging in 1 for y. So negative 2 is greater than 5 times 1 minus 7. So that's 5 minus 7, which is negative 2. Is negative 2 greater than negative 2? No. It's not. If it had said greater than or equal to, then I could say true, because it could be one or the other. And negative 2 is equal to negative 2, but that's not an option here. So this is a false statement. Here, with graphing inequalities, I need to remember a couple of little things here with this. Less than and greater than symbols. If I'm just talking about being less than or greater than, it's going to be all the numbers that are all the numbers, that are less than a certain number or that are greater than a certain number. That means I'm going to use an open dot on a number line when I go to graph it, because the open dot does not include that number. This one, though, because I have the less than or equal to or the greater than or equal to, that's a closed dot because it does include the number. So in that case, I have to close it because it's going to be everything bigger than a certain number or less than a certain number, but also everything that is equal to a certain number. Okay, let's take a look at how we'd actually graph these. So if I take a look at x is greater than 2, what I'm going to do is first I'll just draw a number line.
Troy O'Brien, please report to the main office. Troy.
So I'm going to draw my number line. And I'm going to go ahead and put 0 in the middle. I don't have to put it in the middle, but this was just a 2, so I'm going to do a couple digits here to the right. That's 1 and 2. And then this is going to be -1, -2. Depending on my values for my x value or for my variable would depend on how I'd set up my number line. In this case, though, I'm going to do all the numbers that are greater than 2. In which case, then, I need to circle where 2 is on my number line. Let me get another color here. So I'm going to circle the 2 because it's not including 2, but it's going to be all the numbers that are to the right of 2. So I'm using that symbol right here, and I'm going to go ahead and put it right here. This is that same symbol. I'm just going to darken it in. And then it's everything in between. So I'm going to highlight that line right there. So I have x is greater than 2. It's not including 2. It's all my numbers that are greater than 2. Okay, let's take a look at this next one here. For number 9, it has 5 is greater than or equal to x. Well, this is not acceptable for inequalities. We cannot have the variable after the constant. I always have to have the variable first. So before I even go to graph this, I need to fix this. So what I'm going to do is literally switch it around. So all of this, instead of being 5 is greater than or equal to x, I have to put x first. And that means that x is less than or equal, because I have to switch the sign too, x is less than or equal to 5. Okay, now this I can graph. So the first thing to remember is I need to switch, because the key thing is x must be first. All right, so I'm going to go ahead and draw my number line. And this time I have 5 as my number. So I'm going to kind of start my 0 down here. This will be a -1. And then 1, 2, 3, 4, 5. There's 5. All right, so again, it's everything that is smaller than 5. So I'm going to use that sign right there, which is this sign right here. I'm going to darken in my arrow at the end. And we're talking about 5. Now I have to think, is it just less than, or is it also less than or equal to? It's also equal to. So my circle on 5, is it going to be open or is it going to be closed? It should be closed. So I'm going to color that in because it includes the 5. And then it also includes all these numbers in between, because it's all the numbers that are less than or equal to 5. So I'm just going to darken in that line like so. Okay, now here I'm just naming the inequality from the graph. So I'm taking a look at this. Well, it's an open circle. So it's going to be, and it's going to the left. It's this symbol right here. That means that my x value is going to be this symbol, which is less than, and it's less than -4. It's not equal to -4. It's just everything smaller than -4. Because, again, it's not equaling -4 because it's open circle. Here, this is 10. It's closed, and it's going to the right this way. So this is my symbol. X is going to be this symbol, which is greater than. Actually, though, it's also equal to, because I have to put my equal sign part underneath as well, because it's including the 10, and it's everything that is greater than or equal to 10. Number 12 gets a little tricky. Every single number on my number line is included, except for that one right there. That's open. That means it is not including -9. That means that x does not equal -9. That's exactly what that's saying. It's all the numbers, every other number it could be, but it cannot equal -9. This one here is exactly the opposite. There's only one thing that is included, and that is 16. If that's the only thing included, that means that x is equal to 16. Okay, on this bottom part here, this was your homework basically that I asked you to do. We're going to solve these equations, solving these inequalities the same exact way that we solve an equation. But there's a little exception or a little rule that we need to make sure we know. So I'm going to put a little star here by this because I need to make sure I understand this rule. Here is my rule. Anytime I multiply or divide, so it's only when I multiply or divide, not anything else, just multiply and divide, by a negative coefficient. That means my number with the variable. That number that's right smack dab with the variable or maybe being divided, like the variable being divided by it. I must flip my sign. That's the key thing. I have to flip my sign. All right. I will tell you on these first couple ones, there's absolutely no flipping. We don't have to, except actually take it back. There's a little bit of flipping for a different reason, though. Okay, here, I'm going to solve this the same way.
Sarah Johnson, please.
Okay, I'm going to solve this the same way I would an equation. So I'm going to add 4 to both sides, because that's what I need to get rid of. So n is greater than or equal to 10. And I'm all done. Everything stays the same because there was no multiplication, no division. Here, notice that my u is on the wrong side. Well, I'm not going to worry about that till I'm all done. I'm going to go ahead and do my math like normal, and then at the end I'm going to do my flipping around that I need to do because remember, variable needs to be on the left-hand side or go first. But I'm going to do everything else that we're supposed to do. This is -2, so I'm going to add 2 to both sides. That cancels out. And I get -15 is greater than u. Well, I need to switch it because u needs to come first. So that means that u, switch this to, is less than -15. Nothing happens with the number, guys. It's still a negative. It stays a negative. All we're doing is moving it to the other side. So it's just a -15 stays -15. We're not flipping signs or anything like that. Don't think about that. We're not doing the opposite of anything. We're just moving it around so that the variable is first. So u is less than -15. We just rewrote it the other way. U is less than -15. Okay, here I'm going to get rid of the 8. So I'm going to -8 from both sides. This cancels out. This is a -3 is less than or equal to q. And again, I didn't multiply or divide, so all's good. Everything stays the same. And I did, oh, no, excuse me, I take that back. That's not my final answer because I just got done saying q has to be first. So now I have to flip everything around. That means that q is greater than or equal to -3. There's my answer. Sorry about that. All right, 5 less than a number is at least -2. So 5 less than a number. This is where my, the less than is not meaning my symbol, it's meaning my operation. So 5 less than a number means some number -5 is at least, this is my symbol, is at least -2. Okay, so it's at least -2. That means that's the smallest number it could be. It's -2 is the smallest. It's at least that big. It could be anything more than that, but it's at least that. That means that this has to be greater than or equal to -2. If you need to, refer back to the front side of this worksheet because it talked about those kind of words. But think about what we're talking about. It's all the numbers that are bigger than -2. So all this has to be bigger or equal to -2. It's at least -2 or anything more. Okay, here, now we're on number 5, we're going to start getting into doing some multiplying and dividing. So now we have to watch. Remember, if I multiply or divide by a negative number, that's when I need to flip my sign around at the very last step. So let's see what happens here. This is a divided by 2. I'm going to multiply both sides by 2 to get rid of that, because a divided by 2 timesing by 2 gets rid of it. That's gone. I get a. Is it greater than or less than? It should be greater than because it's going to stay the same. It was a +2. I did not multiply by a negative, so I'm okay. Now this is a negative, but that's a different story. This one that I wrote in is what we're talking about. Negative 2 times positive 2 is a negative 4. And there's my answer for that one. Okay, here, negative 14, n is greater than negative 14. I need to divide both sides by negative 14. That means that n is greater than or less than. It should be less than. We have to switch our sign because we did divide by a negative number, and that should be 1 there. Negative 14 divided by negative 14 is 1. So n is all the numbers that are less than 1. Here we have sort of a two-step going on, so I need to get rid of 2. Minus 2, minus 2. 3k is less than negative 6. Remember, adding or subtracting by a negative does not mean anything. It's when I multiply or divide. So my sign stays the same. Now I'm getting into division. Now I'm going to divide both sides by 3, because 3 is what we're getting rid of next. That means that k is less than negative 2. So again, sign stays the same because I'm dividing by a positive, not a negative. All right, let's take a look at number 8. P divided by negative 8. Oh, excuse me, actually I need to get rid of this first. Let's add 5 to both sides. That's gone. So now I have P divided by negative 8 is less than positive 3. Remember, we're not switching the sign until we actually do a multiplying or dividing by a negative number. This is division, so I'm going to multiply by negative 8, which means I'm going to multiply by negative 8. That cancels out. That means P is greater than, because I'm multiplying by a negative 8, multiplying by a negative number, I should say. 3 times 8 is 24, but it's a negative 24. Last one. Let's get rid of the 5. We're going to add 5 to both sides. That cancels out. Negative 2i is less than or equal to positive 24. We're dividing both sides now by negative 2. So y is greater than or equal to negative 12. Now remember too, I did not do this for the sake of time, but you can plug in all of these answers to see if they work in the original problem. Now this is what I would do though. If you're talking about a number greater than this, then pick a number greater than it. Don't pick the same number. Even here when it's equal to, it doesn't matter. If y is greater than or equal to negative 12, well, a number bigger than negative 12 would be negative 10. I would just go 1 or 2 bigger than it. So I would plug negative 10 in up here, and it should work in this original equation right here. If it doesn't, you may have done something wrong with the sign. So you need to watch if you didn't switch your signs. Next class, we are going to be talking more about this type of problem right here, where we're solving 1- and 2-step inequalities and then graphing them. So we're just going to continue sort of with the same thing, just kicking it up a notch. I hope everybody has a great evening, and enjoy your day off tomorrow, for those of you on A day.